Thank you. So actually, this is a presentation which actually echoes with the previous presentation. And now, why did I choose this particular topic? Right now, I'm working on quality control issues related to the foodstuff. So respectively, this issue is quite topical and relevant to me. As you may appreciate, whenever we speak about analytical process, this is connected to sampling and also preparation of the sample. Then we speak about the third phase, which is about conduct or carrying out of the analysis. And then we need to actually process the data obtained by us. Today, we are going to focus on sampling process. Actually, it may happen so that many of the issues that I'm going to talk about are crystal clear for everyone. You may know about all these issues. And unfortunately, still it happens so that there are still many errors connected to the sampling. That is why I'm going to focus on this phase. What is a sample? In general, a sample is particular part of the object that we are going to analyze, which needs to be taken for further analysis. We are picking a small part of it for further analysis, and then average composition and properties are considered, and they are identical to the average composition of the properties of the object, of the food. And actually, when it comes to the sample and the size of the sample, it all depends on different components that we need to analyze, which is a matter of our interest. And actually here we speak about what could be the size of the sample that we take. Actually, we can classify these samples into different factors. These aspects are mentioned here. One is the random. Then actually there is general or medium or other classifications. And actually after random comes the general, then comes medium, laboratory, analytical, and then quantities and aliquots. Here, two issues as mentioned. One is quantities, and quantities are connected to solid samples and aliquots to liquid samples. And we need to individually look at these factors. So we have random, empiric samples also. These are the samples where we have minimum size of the material, the characteristics of which shall not differ from the main item that we are going to analyze, and this should give us a reliable result based on these specific indicators. And then actually we are talking about the combination of these random samples so that we actually further on carry out further analysis, and these characteristics should be characteristic to that object from where we take the sample. The main sample should be identical to the object of our interest, and it should even be identical to it. You now see here a formula. Tamara, could you please switch on? Further on, please. Now you see a formula, and with this formula, we are going to make the calculation We lost some information on the other slide. Shall I move it up or down? I need the upper part, please. Okay, move up, please. No, down. Yes, here, please.
General sum.
Down, where we have general sum, general sample. Okay, actually, it all depends on the characteristics of the material and the weight of this material. It also depends on different locations from where we can take this random sample. Then all these need to be mixed with each other, blended, so that we take this general sample. So N is the number of those places, and it could vary depending on the weight. Then comes the average sample, and this is the sample, the characteristics of which should be identical to our object of analysis. Here we also speak about laboratory sample, and this is the intermediate, the final intermediate sample that could go to the laboratory for further analysis. And this is the smaller number and size than the initial sample. And then in the laboratory, we take one part for initial analysis. Then the second one is kept and preserved for check, and the third is for analysis. The sample for analysis is the sample on which different analysis is carried out in the laboratory by using different equipment. When taking a sample, it is quite important. This sample should be identical to those samples that we have taken from different locations. And actually that process should be taken into account when planning this process. When it comes to sampling, transportation, preparation for analysis, then this process shall carry out in such a way that these factors do not affect the composition or characteristics of the sample. We are talking about physical or chemical or other characteristics of the sample, and they shall never change. Now, what needs to be taken into account during sampling? When we take the sample, we need to take into account the following factors. First and foremost, the aggregate state of this object that we take as a sample. These samples or this object could be in different aggregate condition, and there is respectively different methodologies for sampling. Different solids are used and different methods. We need to take account homogeneity of this material, and this often happens, especially when it comes to sampling. Also, we need to know what is the required accuracy with which we will carry out this analysis. And much depends on the task of analysis. For each type of these materials, there are particular norms, standards, and rules that should apply according to the international legislation, and these are available according to the international legislation. Then we also speak about the size of the sample.
Yeah.
And also numbers of samples to be taken. How many samples shall we take, or what should be the weight of these units, of these samples? This depends on the type of test, analysis, and particular object. In any case, this size should be sufficient for our tests. And when it comes to the size or weight of the sample, it should be sufficient for extracting the samples for a laboratory test and for preservation or keeping these samples for future work. Also, much depends on the parameters with which we will carry out the analysis. When it comes to size of the laboratory sample and control sample, this size should be sufficient to carry out accurate tests in the laboratory, whether by chromatographic method or other. The size should be considered, and this size depends on specific sample, specific parameters, on specific objects that are analyzed, and everything is strictly specified in relevant normative acts, in different international instruments and standards. I'll be very brief now, and I'll be speaking about transportation related challenges. And here, when it comes to the packaging and the transportation, the physical and chemical characteristics shall not be affected and shall not be changed. So these containers in which the samples are kept should be selected specifically so that even the packaging does not have an impact on chemical and physical characteristics of the sample. Now, there is one particular problem that I would like to speak about. And quite often I encounter with this challenge in our laboratory, and this is related to aflatoxins. And this is about aflatoxins in nuts or different types of products like baked products, bread, and others. And we need to assess the content of mycotoxins, and it all depends on how these products are stored and what is the size of these objects that need to be analyzed. The problem is about the fact that the ESA particles are not distributed evenly in this entire sample. So if we take this sample only from one location, we may have inaccurate results. So what can happen during this situation? There are different methods related to sampling, especially depending on the size of the batch. And there are particular rules for sampling that need to be taken into account. And we are talking about envelope type method. Here, we have a method of sampling bulk or piece material stored in the bulk. Then, depending on the size of the warehouse, we storage, and often it happens so that we identify particular dots and places, it may happen so that we may need 5 or 7 dots, and we can actually take these samples depending on different rules. And these are different dots from where we take these samples. We speak about random method for sampling, and based on it, we take this general sample, and then after we process it, we take it to the laboratory, and it will be analyzed in the laboratory. And then next part, please. Could you please, Tamara, go to the end? This is what I'm talking about. This is example of incorrect sampling. And this is what I was talking about before that. Actually, this is the study of the content of materials. And this is about 2 examples from the literature. And these are from quite well-known journals. The research was carried out on the apple. And I was dealing with this topic. And I had to get familiarized with different material available, and I came across with this challenge. A team of Italian scientists were analyzing contents of minerals in the apples, including phenols. And they were analyzing 15 different varieties of apple, and they were checking everything based on the parameters. And for each sample, they have taken 2 kilos of apple, and they were packed from 3 trees. They were collected from 3 trees. Is such kind of a sample giving a reliable information? Will it give an accurate result to us? I think there are big question marks about it. And there is also reference to particular journal where you can find the information, and there is also a link where you can go for additional information. This was the first example, and now I would like to speak about example number 2. Tamara, go down, please. This is also about analysis in apple, and Spanish team of scientists was working on this test. They compared with each other 5 different varieties of apple to determine total phenol on and procyanidins. And then there is one particular phrase that I quote from this article. And for each variety, they have taken 5 apples. Where was it collected? How it was collected? How it was packed? This is actually a very important information, and definitely based on the information, we cannot say that this is a representative sample. And this article is published in journal Chromatography, and you can actually find more information in this journal. And this is really a well-known journal. It indicates the date when this article is published. And there is also a link to this particular analysis and all these tests. We understand that these were analysis and tests carried out for scientific purposes, but we are talking about the general problem and challenge connected to sampling and accurate results of our analysis based on the process of sampling. And actually, we are talking about these renowned journals where there is strict control for every piece of information. And still, as we say, there could always be some exceptional cases, and these are challenges related to sampling. This can happen quite often, and it happens because different different scientists may simply neglect particular rules connected to sampling process, rules of sampling, or methods of sampling, and many people may actually neglect those different requirements connected to this process of sampling in general. Thank you for your attention. That was brief information from my side. And as far as I know, tomorrow we will actually speak about these issues more.